Welcome students, today is all about chi-squared. This is also called a crosstabs. This is video 1, there will be a follow-up. So we are done with difference testing. We are now moving on to associations. So these aren't quite differences, but they're not quite relationships. There is just some interaction happening between these two variables. With Z and T test, we had continuous information. So all the variables were continuous, but what happens when we don't have continuous information? We just have categorical. This is when we use a chi-squared. So here our keyword is association. So we can explore associations between categories within our variables. This is not a not chai, that's a T. This is chi-squared. And of course we have hypotheses. So the null hypothesis, H0, is that the variables are not associated. Just like our difference test, there was no difference for the null. Here there is no association. Our alternative is that there is an association between the two variables. We don't really do directional hypotheses here. We just do is or isn't. Couple of new vocabulary words. Observed frequency. These are the actual counts for each cell, for each category. So this is the data that we have collected, that we have observed. Then we have expected frequency. These are calculated values of what we would expect to see in each cell. Just to make sure we're clear, rows are horizontal, columns are vertical, and then this is our new symbol. It looks like an X. It usually has a little squiggly on it. Squared, chi-squared. There are a couple assumptions. The expected frequency for each cell should be more than 5, or at least have 20% of the cells that have less than 5. And our chi-square is a new distribution. So we've talked about the Z distribution, the T distribution, the F test, which has an F distribution. This is a new distribution. So of course we have a new table or a new online calculator that we're going to use to find the p-value for that distribution. Just a quick note, chi-squares are very sensitive to sample size. So if we have a small sample, we're less likely to find significance, even if there is significance to be found. So a type 2 error. If we have a large sample, we are more likely to get a significant difference, or a significant association, even if this association is really, really small. We have two types. So this first video is going to focus on tests of association. Second video is going to focus on goodness of fit. So tests of association, we have two variables that we want to see if they are associated. So is there some kind of connection, some interaction happening? And then goodness of fit, we have one variable that we're testing against a standard or goal or expectation. So there's something that we think is happening and we want to see if the variable actually matches our expectation. So the chi-square test of association, I will tell you right now, chi-squares are not hard to calculate. There's just a lot of little steps. So here we have chi-square. Remember this symbol? It means the sum of whatever's behind it. So we have FO, that's the frequency of our observed, minus FE, the frequency of our expected value for that cell squared, divided by the FE. So we're going to do this for every single cell, and then add them all up, and that gives us our chi-square. Degrees freedom for a chi-square is a little bit different. So we have rows minus 1 times columns minus 1. So that's just adding up how many rows were there, how many columns were there. Examples. So there's a bunch of different uses for this. We could look at an association between political party and income bracket. We could look at associations between gender and class grade if the grades were A, B, C, D, and F. If we had continuous variables for grade, so if we had 67%, 92% for everybody, then that would be a T test. Here we just have groups, categories for grade by categories of gender. We could also look at favorite TV show. So categories of show and age, if we group age into teens, 20s, 30s, 40s, 50s, etc. So I said there's a lot of steps. First thing we're going to do is organize it into a table. Then we're going to add up all of the rows, add up the columns. So we'll have a total for each row, a total for each column, and then a total. We're going to calculate our expected values, which is the row total times the column total divided by the total. I know. For each box or cell, we're going to find the observed minus expected squared divided by expected. And we're going to add all these up, and that's our chi-squared. Once we have the chi-square value, we need to figure out the p-value that's associated with that. So we're going to look that up online. And if we have a significant association, then we're going to look for values that are over 2 from step 3. Step 4. Sorry, we're going to look right here. And then these are the specific unexpected results. Easy, right? Don't worry. So here we go. A researcher, me, wants to know if there is an association between favorite ice cream and gender. So I asked a bunch of people from different genders, some male, some female, what their favorite ice cream was. Given 3 choices, I know there's more choices of ice cream, but given these 3, what was your favorite? Chocolate, vanilla, or strawberry? So 43 guys said they like chocolate. 39 women said they like chocolate. 62 men and 62 women said vanilla was their favorite, and then strawberry is kind of low. Step 1, organize it into a table. You will see these yellow boxes that are within this box right here, and then this yellow box is just in this box here. We're going to use those. So we have a table. We're going to add up the rows. We're going to add up the columns and the totals. So 43 plus 39 is 82. 62 is 124. 25 plus 4, 29. Then we're going to add up the column totals. So 43 plus 62 plus 25 is 130. And then we can add up these 2 to get our total. It's the same as if we added up these 3 to get our total. So there's only 235 people that I asked what their favorite ice cream was. Step 3, we're going to calculate the expected value for each cell. So to get the value that we're going to stick right here, I'm going to take the row total times the column total divided by the total. And that's going to give me all of these values. So for this cell, for 39, I'm going to take the row total times the column total divided by the total. And that gives me 36.64. So my observed value is 39. My expected value for that cell was 36.64. Same with all of these. So this one, the row total times column total divided by total. Then, step 4, for each box or for each cell, I'm going to find the observed minus expected squared divided by expected. So this first one right here, 43 minus 45.36 squared, and then divided by 43.36, and I get 0.12. Next cell. 39 minus 36.64 squared divided by 36.64, and I get 0.15. So I do this for every single cell. Then I'm going to add them up, and that 12.8, so I'm adding up these guys right here. That 12.88 is our chi-square value. So we have a chi-square. We need to figure out the degrees freedom because we want to underestimate. So number of rows minus 1. So we had 3 rows minus 1 times the number of columns. We had 2 columns minus 1. So 3 minus 1, 2 times 2 minus 1, 1. Our degrees freedom is 2. Guess where we're going to find our p-value? Google. So we're going to Google chi-square to p-value, and that's going to give us a bunch of different options. I happen to like easy calculation. I type in all of my information. It looks just like the other ones we've used. And I get a p of 0.0008, which we compare to our alpha, which I assume is 0.05 in this case. I have a significant association. So because it is significant, that means that there is an association between gender and favorite ice cream. But I want to know where the differences really are. What are the unexpected results? So to do that, I'm going to go back to these guys. I'm going to scan through them, and I'm looking for values that are over 2. In this case, I have 2 cells that are over 2. So I'm going to figure out what cells those are. So I've got 25 and 16. I'm going to go over here to 25 and 16. This was unexpected, and this was unexpected. So when I look at 25 compared to 16, 25 is more. So there were more men than expected that liked strawberry. Here I have 4 compared to 12, almost 13. So there were less women than expected who liked strawberry. And that's how I'm going to write it up. So I'm going to say I reject the null hypothesis. There is a significant association between gender and favorite ice cream. Here's my chi-square. That's my degrees freedom, 12.88, comma, p-value is less than 0.001. Then I talk about who was more expected or less than expected. So more men chose strawberry than expected, less women chose strawberry than expected. Now it's your turn. So you're going to pause the video and you are going to try this out yourself. I'm not kidding. Right now, pause the video. Try it. And now that we're back, because I know you did this. So again, the first step is to come up with your row totals, your column totals, and your total. We find our expected values for each cell. And then we find the observed minus expected squared divided by expected for each cell. We're going to add up these guys and we get a chi-square of 24.06. We look online once we have our degrees freedom and we find out the p-value is less than 0.001. When I write this up, that means I reject the null hypothesis. There is a significant association between medication and improvement. We have our numbers for chi-square. And then we have to talk about who was more and who was less. In this case, every single cell was over 2 here. So every single cell had an unexpected result. So we say more people, because 50 is more than 36, so more people improved using medication than expected. Here, 20 is less than 33. So less people improved on no medication. It gets kind of awkward talking about this, I know. And we do that for every single cell. So more people, less people, less people, more people, all the way through. Again, here's another example. So an association was found, or we say no association was found if it's not significant, between variable 1 and variable 2, and we give the chi-square. If we have a significant result, then we talk about what was more than expected or less than expected for every cell that is above 2. Before we move on to goodness of fit, review that, make sure you understand the test of association, and then you can move on to video 2.